Hey guys, so in this video we are going to solve bridge edge in a graph problem which is on X4 gigs. So problem said that we are given an undirected graph with v vertices number from 0 to v minus 1, and we have also given, and for that we have given this edges which is a 2D array which represent u to v. That means there will be a bidirectional edge between this u and v, and we have also given this c and d integers, like uh, that will be any vertex, and we have to determine whether this c and d, whether the edge between c and d is a bridge or not. So what this bridge means, like let's suppose there are two cities and the one bridge is connecting between two cities. So as per the definition of the bridge, for for connecting any two cities there will be only a single path, that will be called a bridge. Like if we remove that bridge, so these two cities will be disjoint with each other. So that's the concept we can use. Like here, if we use the definition here, so an edge is called a bridge if removing it increases the number of connected components of a graph. Bridge is there will be any single edge only which can connect any two vertex, and no any other path can form such that these two vertex can be connected with each other. Like for example, let's check this, the first test case. So here c equal to 1 and d equal to 2. So here we can see that there will be only one path which can connect these 1 and 2. So here it is forming a bridge, so we will simply return true here. And for the second test case, so c equal to 0 and d equal to 2. So if we remove this edge, so there will be still one path, that is 0, 1 and 2. So this is not forming a bridge because there are more than one path which is connecting between 0 and 2. So for this test case we will return false. Okay, so here what will be our approach here? If at first we will create one graph, and we have to check whether there is more than one path between c and d. If there are more than one path, that means it will not a bridge, else it will a bridge. Okay, so first I will create one graph. From collection simple default graph equal to default list. Now for I comma j in edges. Now graph of I dot append j, graph of j dot append I. Okay, now let's take one test case where there is one graph and there is also one bridge, but that bridge is not an edge. Like first I will also check whether this bridge between c and d are already exist in my edges or not. Like if this bridge is not present in my edges, that means if we remove anything which is not already absent, so there will be no any effect. So we will simply return true. So here I am creating one count variable, and I will check if I equal, and here it is like undirected graph, so both u to v and v to u direction will be possible. So I will check for both the cases, if I equal to c, or and j equal to d, or I equal to d and j equal to c. That means my count is now 1, and I know that this c and d will form a bridge, so I will not include those edges in my graph. And at the end I will check whether there is any path which are connecting between c and d or not. So at first I am not considering the path between C and D into my graph. Now after this I will check whether this my count is remain 0 or not. That means when my count is 0, if this bridge is not present in my edges, so I will simply return here uh, true, false. Should I return here true or false? So if my count is 0, that means my bridge is not present in my edges. So after removing all or anything, so my graph will remain same. So, okay, so that will be a false. Because my graph will remain same, it will not disjoin. Okay, now I will, okay, so for the next step I am using a BFS approach for traversing between C to D. So for doing BFS I am using a queue. So queue don't get, and I have also making this visited array. And if I have reached to D, that means it is not a bridge, so I will return false. And also if visited of node equals to 1, that means this node is already visited. Now at the end, visit of node equals to 1. Now after mobile graph node, I'm including this neighbor into my queue. Now at the end, if I am not able to connect this C and D, means there is no any path between C and D, so I will return true at the end. So let's fine. Okay, so code is successfully executed. So here what will the time complexity? So here for creating the graph, it is taking big of E, that E means the length of edge or the size of edge, and also for determining the path between C and D. So that for that we are traversing over all the nodes. And how many nodes we have? We have total V number of nodes, V number of vertices. So here the total time complexity will be big of V plus E. And what about the space complexity? So space complexity is we are creating here a graph, and also we are creating this visited array. Same with the queue, but it is like dynamically, but still it is consuming memory. So overall we are using big of V space. Okay, thank you.